Greetings, happy people. Today I'm going to teach us how to factor a cubic polynomial. And our learning objectives are factor by grouping and factor by using the free term. Our philosophy here is we don't just give you the solution, we explain the solution for you. We give you the basics, yeah, give you the basics. So let's start. First is factor by grouping. Assuming we are given this polynomial x cubed plus 2x squared minus x minus 2, what we're gonna do? First, we have to make the polynomial equals to 0. After that, making it equals to 0, we have to group it into 2. Then after grouping into 2, we now have to check in each of the group what is common in each of the group. As you can see, in the first group we have x squared that is common. Squared is common in the first group, and in the second group minus 1 is common. Minus 1 is common in the second group, as you can see. So we now simplify, simplify the group, the roots. You simplify so that we get the roots of the equation, because we are trying to find the roots of this polynomial. Yes, so we are using factorization by grouping or factorization by using the free term to get the roots of this polynomial. So but x squared minus 1 is equals to bracket open x minus root 1 bracket close bracket open x plus root 1 bracket close. We now substitute this into the equation, the roots of the equation. We now have this now, and by inspection we now see that x is equals to 1 or minus 1 or minus 2. So the roots of this equation, it means that if you substitute 1 or minus 1 or minus 2 into the polynomial, you will get 0. You have to note that negative root 1 is equals to negative 1 and positive root 1 is equals to positive 1. So that's all for factorization by grouping. Hope that's simple, right? Yeah. So let's go to the next one. That's factorization by using the free term. So here, as we are giving this to find the roots of this polynomial by using the free term, what we're gonna do? First of all, we'll look at the free term. The free term here is negative 18, or let's say 18. We'll now look what are the factors of 18. Factors of 18, we have 1, we have 2, we have 9, we have 18. So how we're gonna do? What we do is we substitute each of these factor into x, into the equation, as in substituting x for each of these factors to see which one will give us 0. We'll start by using minus 1 plus 1 minus 2 plus 2 minus 9 plus 9 and minus 18 plus 18. The one that gives us will stop and then use that one to solve the rest. So minus 1 doesn't satisfy the equation, we get 6. You're supposed to get 0. Use plus 1 gives us minus 20, which we are not satisfied to. Use minus 2 gives us 4. No. We use 2. Wow, 2 gives us 0. Perfect. This is what we are looking for. It means that x is equals to 2, or x minus 2 satisfies our polynomial and equation. So x minus 2 is one of the roots of the equation. So we have to look for the other 2 roots, because from the polynomial we see is raised to the power of 3. It means that it has 3 roots. So we have gotten one root. Now let's use the rule to find the others. This is the polynomial, and we now have to factor out x minus 2. That's one of the roots from each of this polynomial. We start by 2x cubed. We can't factor out. Can we factor out x minus 2 out of 2x cubed? No. So what we do is we have to borrow minus 4x squared from 5x squared. That's the second variable. We borrow from the second variable, add to the first variable to be able to factor out. So that's it. We add minus 4x squared to the first variable, which is 2x cubed, to be able to factor out x minus 2. So we see how we got it now. I'll be able to factor it out. Now borrow that minus 4x squared, we are left with 9x squared. You can look into the bracket and see how the manipulation worked, how it's being worked out. So we now see, can we factor out x minus 2 out of 9x squared? No. So what we do is we have to borrow again. Borrow minus 18x from the third term, which is 9 minus 9x. We borrow minus 18x. Look into the bracket, you'll see how we did the borrowing. Borrow minus 18x, we'll be left with plus 9x. So when we borrow that, we add that minus 18x to plus 9x squared that is remaining from the second variable, where we borrowed minus 4x squared. So when we add that minus 18x, we'll be able to factor out x minus 2, as you can see in the right hand side. Yes, right hand side. You see the x minus 2 there. Now we are left with plus 9x that was remaining from the third variable, where we borrowed minus 18x. So we have plus 9x and minus 18. That's the constant term. Can we factor out x minus 2 out of what is remaining? That's 9x minus 18. Yes, we can. So we just did here. Yeah, you see, can factor it out, and we get 9 bracket open x minus 2 bracket close. So let's kind of give a summary, arrange what we just did thus far. In the left hand side, you see what happened, and in the right hand side, what happened. As you can see, the last calculation that happened, the 9x minus 18, see in the last phase of this summary. So we now add up all the right hand side, the RHS, add everything up. We add it up, as you can see below there, we have all of that, which is summarized here. So now x minus 2 is already a factor, so we have to solve the other factor. The other is already a root. X minus 2 is already one of the roots. I have to solve for this 2x squared plus 9x plus 9, which is the quadratic equation, to get the two remaining roots of the polynomial. So by inspection, see, we use the factorization method to solve that, to get this. Factorization is trial and error. So you take two numbers that you take any two numbers that you can factor to get what you want. So we have these 2x plus 3 and x plus 3. So finally, x the two roots are x equals to minus 3 over 2 or x equals to minus 3, then it therefore means that x is equals to minus 3 over 2 or minus 3 or 2. That's the three roots of the polynomial. If you find this video helpful, you can make your comments, or you give a thumbs up you like the video, and also you can subscribe so I will get more of videos like this whenever it comes up. So thank you people, and see you when we see. Lights out.